waveguide junctions, TIS applications, series on microwave engineering, lecture number 1.15. TIS are a kind of microwave junctions. They are used either to split a wave or to combine two waves, three waves into one wave. There are three-port Ts. There are also four-port Ts. E-plane T, H-plane T, they belong to the category of three-port Ts, whereas Magic T belongs to the category of four-port Ts. Ts find applications in the design of microwave communication systems, mainly in the design of radar systems. In the present session, the focus is on applications of three-port Ts, the usage of three-port Ts in the design of microwave communication systems. Before going to the applications, certain terms we come across while dealing with Ts, with microwave junctions in general, like port, arm, junction, etc. They are described, they are defined, their meaning is clearly given. Now let us move further into the core session. A few words as an introduction to the session. At microwave frequencies, often it is required to split power into two or more parts, and also two or more streams of power require to be combined into one. Junctions, microwave junctions are devices used for splitting or combining waves at microwave frequency. So this is the definition of junction, microwave junction. Microwave junction is a device which is capable of dividing a wave into two or more parts or combining two or more waves into a single one. These are passive devices and can be made with the sections of coaxial cables or rectangular waveguides. While dealing with the junctions, describing their structure, describing their functioning, certain terms like port, arm, junction region, they are used. Without using them, it is not possible either to describe or to understand. All these terms refer to different portions of the structure of the junctions. First, we consider the term port. Port refers to an opening to which the source or load is connected. Hence, it is an inlet or outlet part of the junction device. H.E. Wheeler introduced the term port in 1950s to replace the phrase two-terminal pair. Two-terminal pair may be appropriate in circuit theory when we are dealing with circuits, but in microwaves, it is far from appropriateness. Anyway, two-terminal pair, this usage has been replaced by port by Wheeler way back in the 1950s. Arms or other parts of these devices. These are pieces of transmission lines or waveguides or coaxial lines with which the junction device is fabricated. Waveguide pieces, coaxial line pieces, they are arms. Third term is junction region. It is a region, it is a space which is actually a common space where all the arms of the device meet each other. So port is opening, arms are waveguide pieces or coaxial pieces. Junction is common region. Depending upon the manner in which a port is located in relation to the overall structure of the device, it can be matched or mismatched to the junction. Two ports, depending upon their locations with respect to the junction region, they can be isolated or connected. The purpose of these two statements is to introduce the terms matched and isolate. We come across these two terms so frequently in microwave engineering in dealing with circuits, microwave circuits, that we need to be very clear. We need to have a total understanding regarding these two terms. By definition, a port is said to be perfectly matched to the junction only when nothing out of the power incident at the port is reflected back by the junction. Let us suppose here is some circuit junction. Let us suppose here is a port. This port is said to be matched to the junction circuit when the power that has flown towards the junction, if that power goes into the junction completely, totally, without any reflections, nothing should be reflected back towards the port where source is connected, then the port is said to be perfectly matched. If reflection is there, it may be even a small portion of the incident wave, then the port is no more perfectly matched. Again, by definition, two ports are said to be perfectly isolated if nothing out of the power incident at one port appears at the other port. To describe the meaning of perfect isolation, consider two ports. Let us say this is one port, here is another port. Now, let us suppose a source is connected at port 1. The source drives some power, a wave, into the junction. Nothing out of this appears at port 2, then one says 1 and 2 are perfectly isolated from each other. Here are shown diagrams of junctions. E plane T, H plane T, magic T. E plane T, H plane T. They are three port devices. 1, 2, 3. 1, 2, 3. E plane T is called E plane T because side arm is in E plane. H plane T is called H plane T because side arm is in H plane. Also notice the existence of 180 degrees phase shift between the outputs when input is given into sidearm port in case of E plane T. In case of H plane T, output fields are in phase when input is connected to port 3. Also, it requires to be mentioned the fact that these are called T's because they are in the shape of English capital letter T. In case of E plane T, its shape is T standing over its head. In case of H plane T, T lying down on his side. Now, in the third diagram, the structure of magic T is illustrated. It is a 4-port device. One can notice it is a combination of E plane T and H plane T. Both are there. When we combine the both, the resultant is magic. Then, why it is called magic T? What is the meaning of magic? Why the term magic is used? In the name of magic T, there is an element of surprise. There is an element of unexpected behavior in magic T's functionality. What is that surprise element? Suppose input is connected at port 1. A wave is injected into the device at port 1 here. Common sense says this wave straight away traveling and appearing at port 2 because there is no obstruction. One can see port 2 from port 1, port 1 from port 2. No obstacle, no obstruction in between port 1 and 2. Physical obstruction. So we expect the wave reaching port 2. Similarly, when you connect a source at port 2, we expect the output of the source traveling and appearing at port 1. This is common sense. This expectation is out of common sense. But in practice, input at 1, it cannot reach and appear at port 2. Input at port 2, it cannot reach port 1 and come out. It is against common sense. It is magic. That's why it is called magic. Another junction device is shown here. It is directional coupler. Directional coupler is a 4-port junction like magic. The basic difference between magic T and directional coupler from the user point of view is magic T can divide a wave only into two equal halves. It is a 3 dB splitter. If we give a wave, half appears at one port, another half at other output port. Division is equal, but there exist applications where we need the division of waves into two parts, not equal parts. Sometimes we need to divert 1/10 of power in a wave, or sometimes we may need 1/100th of the power to be diverted. Sometimes we need 1,000th of the power in the wave to be diverted. For such situations, magic T is not suitable. We have to go to directional coupler. Here is shown two-hole directional coupler, a type of directional coupler. Last one is a rat race coupler. This is also a junction. It is a ring with a mean circumference of 1.5 lambda g. It is also 4-port device. It is also like magic T, 3 dB coupler. Lot of similarity is there between rat race and magic T in terms of their working. Now we consider applications, various important applications of 3-port Ts. These are used as tuners by placing a short circuit in the symmetrical arm. These are used as power dividers and adders. They are also used in duplexer assemblies of radar installation. Tuner. How they are used as tuners? What is tuner? Tuner is a circuit which is used to change the frequency. Tuner is a circuit which helps us in varying the frequency. As a tuner, a movable shaft is placed in the side arm. Side arm means E arm in E plenty, H arm in H plenty. So a shaft is placed in the side arm. Input is connected to one of the collinear arm ports and output is extracted from the other collinear port. By changing the depth of insertion of the shaft into the side arm, the susceptance offered by the junction can be varied. The change in the susceptance is used for tuning purpose. Applications as dividers. As divider, the source is connected to the side arm port and the divided power is extracted into the loads connected to the collinear arm ports. In case of power addition, sources are connected to collinear arm ports and the load to the side arm port. The behavior of the T's as dividers and combiners. It is described at length in other sessions. We consider another important application of 3-port T's in the design of duplexer assemblies. What are duplexers? Duplexers allow a single antenna to serve both the transmitter and receiver. In any wireless communication system, usually transmitter requires one antenna, receiver requires another antenna. So two antennas are required. But with the help of duplexer, when duplexer is used, a single antenna can be used both for transmission as well as reception. Naturally, the system cost comes down, system becomes less expensive. On transmission, it protects the receiver from burnout or damage, and on reception, it channels the echo signal to the receiver. In typical duplexer applications, the transmitter peak power are around a megawatt, whereas receivers can tolerate only powers that are less than a watt. Notice, transmitting antenna, it must have the capability to handle megawatts of power. So it is designed to handle such a higher levels of powers. A part of the transmitter circuit also, it requires to withstand higher power levels and it is designed accordingly. Whereas the receiving antenna sensitivity is important as far as receiving antenna is concerned. Normally, it is designed to handle lower power levels but with higher levels of sensitivity. Now, one can understand the danger of transmitter power directly entering into receiver, receiving antenna, and the circuitry that is connected to the receiving antenna, which is designed to handle smaller power levels. Simply burnout takes place because transmitter output is in megawatts, receiving antenna and its associated circuitry, part of receiver. They are designed to handle small power levels, maybe milliwatts or microwatts. It should be avoided. Therefore, a duplexer which makes us establishing communication system with a single antenna. It requires to provide an isolation of 60 dB between transmitter and receiver with only negligible loss of desired signal. Some important points regarding duplexer. Duplexers are ordinarily use resonant sections of line or resonant cavities between the antenna and the transmitter and receiver. They incorporate a device that automatically short circuits the receiver during transmission period. In practice, duplexers use either coaxial lines or waveguides, but for the sake of clarity, parallel wire lines are shown in the basic circuits. Here is a shown microwave duplexer circuits employing series junction in A, shunt junction in B. When transmitter is working, TR tube is fired. It is a short circuit now. So receiver is isolated from transmitter. At a distance of lambda g by 2, a short is reflected as a short. So here is a short. The entire transmitter output is diverted to antenna. When transmitter is not working, here is an open circuit. The length L is selected in such a way that antenna output entirely is diverted towards receiver. This is the way things work in case of series junction. In case of shunt junction, it is almost same as when series junction is employed. When transmitter is giving out power, TR tube gets fired. It is a short. A short at a distance of quarter wave length. It appears as open. It is open. Open circuit exists across the line. The transmitter power entirely goes to antenna. When transmitter is not working, this is open circuit. Here is a short circuit across the line. So the receiver, here is the antenna. Antenna output is diverted to the receiver because the short is here, it is shorted. So output of the antenna is towards receiver. In duplexers, E plane and H plane Ts are used to connect antenna, transmitter and receiver. The TR stands for transmit receive. Tube breaks down and short circuits the receiver during transmission and deionize quickly once the power is removed. Because of half wavelength distance from short, the impedance of the receiver branch at the junction is 0. And practically all of the transmitted power is delivered to the matched antenna. The distance L is selected in such a way that impedance at junction toward the transmitter is low, so that most of the energy is picked up during the reception. In H plane T version, the TR tube is connected at a distance of quarter wavelength and the distance D is adjusted in such a way that the impedance at the junction toward transmitter is high. These two types require careful readjustment and inconvenience of the distance between transmitter and junction whenever changes are made in the transmitter. To avoid this drawback, 4-port junction duplexers are designed. Two methods are usually employed for this design: branch type and also balanced type duplexers. These two are older types. These two fall into one method where gas TR tubes are used for necessary switching action. In the second method or other method, a ferrite circulator is used to separate the transmitter and receiver. It also uses a gas TR tube and a diode limiter. These are the things which I want to share with you for right now. To recap, various terms, critical terms pertaining to the structure of microwave junctions like port, arm, junction. They are all introduced, described, and explained. Different types of junctions, 3-port junctions, 4-port junctions, they are introduced, and a brief description about them is also given. Then we concluded the session with an elaborate discussion on the applications of 3-port Ts. Hope you have a wonderful, beautiful, successful, enriching, transformative learning experience. Enough for now. See you soon again in another session. Bye bye.